exponents and radicals. So hopefully the rules of exponents that we see in front of us are familiar. So I wanted to kind of go through a quick review before we start to apply them to various algebraic expressions and a series of examples in just a moment. So first of all, recall that a zero exponent, if we have anything raised to the 0 power, so that's going to equal 1. So that's 5 to the 0, 10 to the 0. If it's in parentheses, negative 6 to the 0 power is going to equal 1. When we're multiplying like bases, so like what we see here, if we have some number being raised to an exponent times that same number being raised to an exponent, then we can just add those exponents. So if I have, let's say, 2 to the 3rd times 2 to the 5th, then my base is going to stay the same. It's still going to be 2, but I'm just going to add those exponents. 3 plus 5 makes 8. And the reason it stays the same base, is if we were to write this out the long way, this would be a series of 3 2's multiplying each other. Here'd be another 5, 4, 5 2's. So we can pretty easily see that we're going to be able to combine that into 2, the same number being raised to the 8th power. So that's why we add the exponents. When we're dividing like bases, then of course we're going to subtract the exponents. Makes sense if we think about it as like a reducing situation. 2 to the 5th over 2 to the 3rd would leave us with just 2 to the 2nd. We're just really just shortcutting the cross-canceling, the reducing. So that's for quotients. If we're raising an exponent to an exponent, then we're going to multiply those exponents. So this is an example of that. So let's say we add this 2 to the 3rd to the 5th power. In that case, that would be like having 5 2 to the 3rds all multiplying each other, which would mean we would end up with 15 as our exponent in that case. So when raising an exponent to an exponent, we're going to multiply those exponents. And then the last idea that's on the page here with negative exponents, the best way to kind of think of a negative exponent is that that number is in the wrong place. So if we have a negative exponent in the numerator, then that exponent turns into a positive if we move that number to the denominator. So for example, if we have 2 to the negative 3rd, I can rewrite that as 1 over 2 to the positive 3rd. The key here is to remember that a negative exponent does not mean the number is negative. It's still going to be a positive number. 2 to the negative 3rd is the same as 1 over 2 to the 3rd. Those are both positive numbers, just written with the positive exponent. And so that would be 1 over, not 6, but 1 over 8, of course. 2 times 2 times 2 gives us 8. And then likewise, if I have a negative exponent in the denominator of an expression, then that means that number is in the wrong place, so I can move it up to the numerator to make it positive, positive exponent. Again, the number is still positive in both circumstances, it's just in the wrong place. So if we have 1 over 3 to the negative 2nd, I can rewrite that as 3 to the positive 2nd. I can move that number up into the numerator and make the exponent positive. And so then we can just simplify that into 9 if we wanted to. Again, not 6. And then finally, if we have a fraction that's being raised to a negative exponent, well then that's just telling us that everything is in the wrong place. So really the fastest way to handle that type of situation is to just change the exponent to its positive equivalent, as we see here, but then flip the fraction that's on the inside. And so then at that point we can go ahead and apply that exponent to each of the individual numbers. We could have done it in the reverse order, made it a to the negative m over b to the negative m, and then switched it so that all the exponents would be positive. It would work exactly the same. We'd end up with the same result. So again, just a review here of the various properties of exponents. So let's put some of these rules into practice. So again, there's a variety of ways that we can approach these questions. The way I'm going to go through these is not the only sequence of events that you have to follow in order to successfully simplify these expressions so that we have no negative exponents in our final answer. But it's the way I think it's cleanest and easiest that leads to the fewest mistakes. And so for starters, I'm going to begin inside, on this first example, I'm going to start inside each of the sets of parentheses and make it so that the exponents on the inside are all positive. I generally try to make it so that the exponents on the, are positive whenever possible. That's where we eventually have to end up anyway, according to the directions, so we might as well start inside the parentheses and work our way out. So in this first piece here, x squared y to the negative third, the x squared is in the correct place, so we'll leave that up in the numerator. But then that y to the negative third is in the wrong place with that negative exponent, so I'm going to move it to the denominator. And then I still have the squared exponent there on the outside. So then for the second set of parentheses, I'm going to do the same thing. So I've got x to the negative third, so that's in the wrong place, so I'm going to move that x to the denominator, but then that y with no exponent, which is really a 1, hopefully we remember that, is going to just stay up in the numerator. So, and then we still have the negative 3 exponent on the outside. So now I'm going to leave that first fraction as is, so I'm going to leave this x squared over y to the third squared. I'm going to leave it, but then this second piece here, I'm going to apply that rule that we saw at the tail end of the previous slide with the negative exponent outside of a fraction. So what I'm going to do is I'm going to flip the fraction on the inside and make that 3 exponent positive. So I'm going to have x to the third over y, so I've flipped that to its reciprocal, but now that means that outside exponent is positive. Now I'm going to take those exponents outside of each of the sets of parentheses and apply them to the inside, which means I'm going to be raising an exponent to an exponent. So I'm going to multiply those exponents. So x squared raised to the second power is going to be x to the 2 times 2 is 4. And then in the denominator, y to the third squared, 3 times 2 means I'm going to have y to the 6th. And then I'm going to multiply that times the second fraction is going to become x to the 9th. 3 times 3, raising that exponent to its own exponent, gives us x to the 9th over, and then again, remember that's y to the 1st, so 1 times 3 gives us y to the 3rd. And so then in our last step, we can clean this up a little bit. Note that that's a 4 exponent there. So now we're multiplying like bases on the top. So x to the 4th times x to the 9th, we're going to combine those exponents to make x to the 13th. We're going to add those exponents when we multiply like bases, and then down in the denominator it'll be y to the 6th times y to the 3rd. So add those exponents, we get y to the 9th. So there is our simplified expression there. We have just a single x being raised to the positive exponent of 13, single y being raised to a positive exponent as well. In our second example, I'm going to take a similar approach. I'm going to work on the fraction that's inside of the parentheses before I deal with that negative exponent on the outside. I'm going to do everything I can inside the parentheses, making the exponents positive, simplifying where I can, and then I'll apply that outside exponent. Again, you could apply that outside exponent from the very beginning. As long as you do it correctly, it would be just fine. So if we go with that, so I'm still going to have the negative 2 exponent out here. And the first thing, the 3 over 15. There's no exponent attached to either one of those. So in the numerator, that 3x squared, the x squared, the squared only refers to the x, not to the 3. So I can go ahead and just reduce this 3/15 into 1/5. So I've got that taken care of. Now I'm going to just move these other variable pieces so that all their exponents are positive, and then I'll do my simplifying. So x squared, going to stay up top because it's a positive exponent. X to the negative 5th on the bottom, I'm going to move that up so that it has a positive exponent. That y to the negative 4th on the top, I'm going to move that down to make it y to the positive 4th. And then that y to the negative 2nd on the bottom is going to get moved up. So I've got y to the 2nd up top. So now I've rewritten it, I simplified the 3/15, and I've moved all of the variables so that all of their exponents are positive. So now I'm going to start to combine the exponents on those variables. So up in the numerator, I've got x to the second times x to the fifth. So that's going to combine to give us x to the seventh. And then with the denominator, I still have a 5 down here on the bottom. And then with the y's, I have a y to the fourth on the bottom. I have a y to the second on the top. So I'm going to subtract those exponents. But instead of going 2 minus 4 and then ending up with a negative exponent on the top, I'm just going to take the larger exponent on the bottom and subtract the smaller exponent on the top. But then that means that my result is going to be in the denominator. So we end up with a y squared in the bottom. Then again, we still have that negative 2 exponent on the outside. So then I'm going to apply that rule with the negative exponent on the outside of a fraction. So I'm going to flip the inside fraction. Everything's just going to end up as, the fraction's just going to end up as a reciprocal, but the exponent now will be positive on the outside. So I'm going to have 5 y squared over x to the seventh, but now to the positive second power. And now I'm going to square everything inside the parentheses to finish this out. And don't forget to apply that exponent to the number as well. So it's going to be 5 squared is 25, y to the second squared, so 2 times 2. Remember, power to a power, we multiply those exponents, so we get y to the fourth. And then finally, x to the seventh raised to the second power gives us x to the, not ninth, but x to the 14th, 2 times 7. So here is our simplified result.